Thanks, Steve. Like you said, I'm Jim Weaver with the EPA Office of Research and Development, and I really appreciate the opportunity to come and talk to this group in particular because we come about this from a different point of view than I think most of the rest of the people here, and that's because our work supports EPA's Office of Underground Storage Tanks. And so before I go on, let me acknowledge my colleagues Andrew Murray and Fran Kramer, who work in our Cincinnati office. I'm located at a research lab in southern Oklahoma, Ada, Oklahoma, which is about 3 hours north of Dallas. So as I said, our work supports EPA's Office of Underground Storage Tanks, and I put this up here to remind myself. These are the regulated underground storage tanks in Oklahoma. The Oklahoma Corporation Commission is the agency in the state that has jurisdiction. There's something like 14,000 regulated tanks. And just to give you a little history on the nationwide underground storage tank program, when the program started back in the late 80s, there were 1.5 million underground storage tanks that primarily stored fuels in the United States. And throughout a 10-year upgrade period, over 500,000 confirmed releases were reported. So roughly 1 in 3 tanks have been found to have leaked. Now we're at a point where we have about 750,000 nationwide. And of that original number of leaks, there's still around 70,000 open leaking underground storage tank sites or LUS sites. There's around 70,000 left to be cleaned up. And the rate of new ones being added is around 3,000 to 5,000 a year. So we're continuing to have leaks from underground storage tanks despite the best effort. And so we're interested in private wells because private wells represent one of the 2 major uncontrolled exposure pathways from a leaking underground storage tanks. The one that I'm not going to talk about today is vapor intrusion. So we have some work on vapor intrusion. And then the second major uncontrolled pathway is people drinking from private domestic wells. So we started out with this simple question of just where are the wells located? And of course, at first brush, you would think, well, let's just go to the state and find out. And this shows the reported domestic wells that the Oklahoma Water Resources Board has, and in fact, you can go on their website and you can see this is what somebody called yesterday dots on the map. And so these are all the wells reported to the state. And they're plotting on top of each other, so you see a tremendous number of them. And because of that, there's a little bit of information that's not totally visible here, just because there's areas blocked out. Another bit of information that the dots on the map don't show you is when were these reported. And you'll notice this is the cumulative number of domestic wells reported to the Oklahoma Water Resources Board from 1900 through about 2015, I think it should go. And what you'll notice is in the mid-'80s, they began to spike up in one of these hockey stick type graphs. And the reason they spike up in the 1980s is because that's when the state put in a requirement that the drillers had to report their logs. Okay, and if you just look and can see clearly enough, just remember these 2 numbers. In 1990 will become very important, there were about 15,000 wells reported to the state. I think the total represented on this figure is around 70,000, but in 1990, there were around 15,000 had been reported. Okay, so what about this as a data source? Well, well logs vary tremendously by state through a number of things. As I just mentioned, the historical duration of the data collection, it varies state by state. Some states started early. Arizona started pretty early. Other states have started around the 1980s. So there's a question of completeness because of that. There's also a question of availability. Some states have not had the resources to compile their well logs. They're sitting on paper copies in files versus some states that have them compiled electronically, like Oklahoma and several other states that we've looked at do. And then availability, if taken to the extreme, there's some situations where it has not been legal to disclose that information. California being one until very recently could not disclose any data sources or any locations of private wells. And in fact, this spring, we had the experience of doing a little enforcement project for our Region 9 office in San Francisco, and we were looking at a very small area within the state, just a couple of sections of public land sections, and they wanted like $100 to get these data. And so it's not really freely available even at this time, although they told us they're working on it. Okay, so well logs are a potential data source. What are some of the alternatives? The first one was mentioned yesterday. You can do a negative inference. So you could, in theory, go to all the water purveyors and find out where the water mains are and find out who all their customers are. Well, in Oklahoma alone, we have 747 public water systems. And as an employee of the federal government, I'm not allowed to ask people to give information like that. And in fact, it bears into this issue of conducting a survey. If the federal government conducts a survey, which is defined as asking more than 10 people the same question, you have to have approval from the Office of Management and Budget. And so it's very unlikely that we're going to conduct a survey like that. I'll tell you though, I've talked to directors of some of the water utilities in Oklahoma, and they've, in very good faith, offered me maps and such, and sometimes they actually give them to me and sometimes they don't. So, and the same thing with counties. They're overwhelmed with work, and so even good-intentioned people sometimes don't follow through. And I wouldn't want to have to rely on being able to get everybody's data. Counties are similar. There's some county health departments may have data. Some counties, although not in Oklahoma, their assessor records may indicate where there's private wells. But once again, I face the problem of there being 77 counties in Oklahoma, and it would be difficult to get that data. Okay, now if we go up in scale and start thinking outside the box, the American Community Survey, which is part of the US Census Bureau, has a question that they ask on the cost of water and sewer. So you can infer that if people are not paying anything for these, they might be using a private well, and that would be very likely. But the problem is that they only ask 55,000 people around the country or households. And so as a consequence, they cannot distribute data down to even a county or even a state scale. Okay, and so the last thing that we've started looking at and started using extensively is the 1990 census. And so that's why 1990 is important. And the US Congress authorized a census of housing beginning in 1939. And from 1960 until 1990, the long form of the census asked the question, do you get your water from a public water system or a drilled well or a dug well or other? And so we have begun using the 1990 census as the basis for our estimates of private well use. Okay, this is the 1990 census inference for the state of Oklahoma, and it's down to the census block group level. We work on county scale, census tract scale, and census block group scale. The block groups are designed by the Census Bureau to have about 1,000 people in them. A smaller scale they use is a census block. We don't use that because they can't report this data down to that fine a scale. So looking at the 1990 census results for Oklahoma on the census block group scale, you'll see that there's a large concentration of use of private wells in the center of the state, which just so happens to be where Oklahoma City is located. And it turns out that the highest density of use of private domestic wells in Oklahoma is in a ring around Oklahoma City, primarily the northern and eastern side of the city. Now, interestingly, if you move to the upper right, to the northeast, you'll see our second largest city, Tulsa, which doesn't show that same pattern at all. And we've looked into why that's the case, and I'll just hold everybody in suspense for a little while before I give what our reasoning is. And then I'll mention, just for future reference, north and slightly east of Oklahoma City is Enid, Oklahoma, and you'll notice that it's sitting on a spot with high use of private wells also. And Enid was a bit of a mystery that I'll talk about later. Okay, so this is from 1990. Okay, and so we have developed methods that then project this into the future. Being that it's over 25 years ago, how do we project this to a more current estimate? So we have two methods, and the first one we call the reported wells method, which we start with the 1990 estimate, add the wells reported to the state, and so that's going to increase, it can only increase, and then we subtract off the loss of housing units. So there's going to be some rate of wells going out of use. We have rural areas that are depopulating, so there's some that are going to be lost. And so we subtract off housing unit loss, that's from the Census Bureau, times a fraction of well use. So if the fraction of well use is 9%, which roughly it is across the state, we would subtract off 9% of the housing units lost. Our second method is called net housing units. It only relies on US Census Bureau data, and it starts again with the 1990 estimate, adds a net addition of housing units, once again times a fraction of well use. Reported wells is conceptually our best approach because those reported wells give you what's shifting around since 1990. So that would be the preferred approach, but given the limitations in state data, we can't project to the whole country with what we have in hand right now. And I'm going to get to a projection for the whole country near the end. But just to keep in mind, we have two methods: reported wells, which relies on state data, net housing units, US Census Bureau data only. Okay, so here's a prediction, and this is from reported wells for 2010 based on the county scale. And you'll notice that it roughly matches what we saw in the 1990 census results. And in fact, that the highest density of private well use is in the center of the state, with some over on the northeastern border between us, Missouri and Arkansas. Okay, and the thing about this prediction is, there's two things about it. One is obvious. By looking at it, you've lost all the detail. So for our purposes and our interest, the county scale is too big. So we want to keep with those smaller scales. The other thing that's not evident is that this has no significantly statistical difference between the 1990 census at this scale. So I think for a couple reasons, at least for us, the county isn't particularly a good scale to work at. Okay, so this one then shows 2010 estimates for census tracts, census block groups, housing units, and reported wells. So I've packed all this into one slide. And what you'll notice, first of all, is that all four of these have a generally similar looking characteristic to them. They all look fairly similar. You have to really look close to see the difference in size between the census tracts and the census block groups. Census tracts typically consume or are composed of 3 to 5 census block groups, so they're not hugely bigger, but they are somewhat bigger. So, but given this, you see that for 2010, the same thing is happening in that there's this high density of private well use in the center of the state, and if you could see it up close, you'd see that there's still this ring around Oklahoma City, particularly to the north and east. And then once again, a really high region over on the border with Missouri and Arkansas. Now, it turns out that at the census block group scale, we do have statistically significant differences between these estimates and the 1990 census results. So these are showing change from 1990. This one shows change in a more obvious way. Everything that's colored in red has had an increase in private well use, and everything that's colored in blue has had a decrease. And so you see that there's a very heterogeneous pattern of increases in private well use. If you look in the center near the Oklahoma City area, there's places where the well use has increased around the edges of the city, and it's decreased some within the city itself. I think that's all I wanted to say about that. Okay, so why is Tulsa different than Oklahoma City? Well, we think there's a fairly simple answer for that. This is a map from the Oklahoma Water Resources Board of the major aquifers in the state of Oklahoma. The green ones are the hard rock aquifers, and if you look right in the center where the name Oklahoma City should be, there's a green aquifer there. And so Oklahoma sits on top of a productive aquifer. Oklahoma City sits on top of a productive aquifer. The brown ones are alluvial aquifers, and if you move up to where Tulsa is, up to the northeast, you'll see, in fact, Tulsa is along the Arkansas River, and there's a little bit of private well use in the alluvial aquifer along the river, but not much in the surrounding area. Tulsa is underlain by interbedded shales and coal, and so there is not the opportunity for extensive reliance on private wells in the Tulsa area. That also matches this map showing the water system boundaries. This is a very approximate map that dates back to 1995. It's the most up-to-date one that the state has, and it shows the areas of public water, including our extensive rural system of rural water districts. And in fact, if you look a bit to the west of Oklahoma City, where you can see the word weather, or for Weatherford, you'll notice there's that strip that's kind of going off to the northwest. That's along the Canadian River. And so if I went back to the dots on the map, you would be able to see that it's filled in with a lot of private wells. Okay, and so over in the Tulsa area, there's much more reliance on public water, partly by necessity, partly by availability. There's a lot more opportunity to use surface water over there because it's the wetter part of the state drying out dramatically as you go to the west. Okay, so to continue looking at why do we see some of the effects that we see, this figure goes back to dots on the map, and it shows the area around Oklahoma City, and it shows that zone where the three arrows go of where there's this very high density of private well use on the outskirts of the city. But you'll notice I've circled this area, which is within the city limits, and it is the independent city of Bethany. Bethany had homes built in the 1940s, and each one had a private well. Bethany now has a public water system, but these well owners and well use persists in Bethany. And what we found in talking to well owners around the state is that one of the simple reasons for not switching to city water is cost. So they don't want to pay the connection fee necessarily, nor do they might want to not pay the monthly water bill. You can see if you go a little bit to the northeast, there's another cluster, and I'll talk about those areas in a minute. This is Edmond, Oklahoma. Edmond is what I call a satellite city, for lack of a better word. It sits just to the northern boundary of Oklahoma City, and it has an old part of the town, the historic part, which is largely covered by the public water system, which is the crosshatched gray area. And so that consists of the older part of the city. Edmond expanded its boundaries to what you see here as early by 1976. And so it's only until recently that any water mains are being built out into that area. And the explanation for that is that the city doesn't invest in the water infrastructure until there's people out there to help pay for it. So neighborhoods are getting established on what had formerly been rural land, and these subdivisions are going in. I circled one, and this place was built out beginning in 2005. So every well was under the reporting requirements by the State Water Resources Board. And that is actually a quarter section subdivision development. There are there's 77 homes there, and 55 of those wells we went and found in the state records. So despite the requirement for reporting logs, they aren't all reported. We went and looked at similar neighborhoods around central Oklahoma, and we found reporting rates that varied from 20% up to 98%. So the state knows that there's quite a variability in the reporting of wells. This just shows it now aggregated to the colored map areas, these being the census block groups. Nakoma Park is another independent city just to the east of Oklahoma City. It has no water system at all. These are areas that resisted incorporation within the boundaries of Oklahoma City, so Oklahoma City didn't extend water lines. Nakoma Park, interestingly though, has a sewer system that reaches 3/4 of the homes, but no water system. In this one you see there's not many wells that have been reported to the state relative to the density of residents. There's something like 500 residences per square mile. If in a square mile you can have acre lots, that would be 640 residences per square mile at maximum. And so it's very plausible that there's that number of wells, which was borne out in our prediction for that area. The last one I'll mention specifically is Enid. Enid, Oklahoma is where I thought the house of cards was tumbling down, because Enid has extensive use of public water, but they also have a lot of private wells. And this took some investigation, but what I found is that most of those wells are shallow, much shallower than the other ones we've been looking at. They're only 50 to 60 feet deep. They run right along the streets in Enid, and they're predominantly used for lawn watering. So people in Enid like to water their lawns. This was discovered in part when Enid put on a total outdoor watering ban during the drought of 2011 and 12, and the drillers were reporting getting 30 to 40 calls a day for people installing these lawn watering wells. Now, ironically, this draws water from the same aquifer that the public system draws from, so it may have not decreased water use. Okay, I'm getting to the end where I need to be, given the time.
You got a couple extra minutes.
Okay.
You started late, that's my bad.
Okay. Well, it's good to discourage me from talking longer. Okay, so like I said, our goal was to extend this to the whole United States. And so we've done this with our housing unit method. So there's no state data here. This is purely done from US Census data. It's done on the basis of housing units added to the 1990 census estimate. And there's some interesting features here, and you could look at Oklahoma and you'll see the same thing I've been talking about, this ring around Oklahoma City. You see that replicated in other cities, particularly in the eastern United States. So I can look at this and I can see it around where I think Minneapolis is, Indianapolis, East St. Louis, Atlanta, I think Pittsburgh. You see this, this area of high reliance on private wells outside the center city, and that's attributed to expanding cities that are not expanding their infrastructure as fast as their boundaries. Also in the East Coast, eastern Pennsylvania, New Jersey, on up into New England, you see high reliance, eastern North Carolina, some in Virginia. then in the Central Valley of California and the western areas of Oregon and Washington State. Okay, so for our net housing unit method, we're able to increase the resolution by going down to the census block scale. And we can do that because housing units are 100% surveyed and not sampled. So the 1990 census results were from the long form, which is a sample. The housing units is directly counted at 100%. And so they release that data to the census block level. And what this reveals, additionally, are these large areas, particularly in the western United States, where there are not many people, if any, living. And so you start seeing a better resolution of areas that don't have private well use because there's simply no people out there. So we're using this as our most refined set of estimates. Okay, so I've managed to go about 20 slides without talking about leaking underground storage tanks. And so part of our charge has been to help the Office of Underground Storage Tanks understand the potential for impacts from leaks. And so what we've been doing is taking underground storage tank locations and then matching them up with our estimates of private well density. And this is a GIS tool that we're developing. And what we've done is we've taken every, in this case, leaking tank, and we've looked at the principal direction of groundwater flow that we infer from topography, and then we go out a certain distance. And that distance is right now 1,000 feet. And that has to do with how far fuel plumes tend to migrate in the aquifer and how far state agencies want to look. And about 1,000 feet is where most agencies want to look right now. And so what you see is these are now color-coded by the number of wells that are potentially impacted. And so with this tool, we can look at a glance, and we see this one down in the lower right-hand corner that's colored red. That is the one that has the potential for impacting the most private wells. So since our results are all based on estimates, we don't discount local knowledge at all. I mean, local knowledge needs to be used, and we wouldn't say this is a way to screen in or screen out an area for potential impacts of private wells. It's an area where the state, when they do their lust investigation, needs to start that door-to-door survey to make sure that there's not people being impacted. Okay, and so then just to review, 1990 really is the only nationwide baseline that's available on private domestic wells. We're advancing our estimates by U.S. Census Bureau data and reported well logs when they're available. I said earlier that's our conceptually preferred method, because those reported well logs and where they've been reported give us an idea of how things are shifting over time, shifting since 1990. And we've seen that in the Oklahoma results, that blue and red colored one. And then we've moved down to a census block group and census block where we can for improved estimates. And then my last slide, just to kind of generalize what we've learned. Obviously, there's high reliance on private wells in rural areas without public water. What I call exurbs or expanding satellite cities. These territories have expanded ahead of the water mains. They have high reliance, like in Edmond, Oklahoma. Unannexed areas like Nakoma Park, unincorporated areas, which I had briefly showed but didn't talk about. Then these enclaves within cities like Bethany, Oklahoma, that dates back to the 1940s. So these enclaves can persist for a very long time period, even when public water is provided. And then you have unique locations of personal preference, like Enid, with their preference for lawn watering. And I will leave you at the Brown Palace Hotel in downtown Denver, who are very proud of the fact that they supply water to their hotel through their own well. 750 feet below downtown Denver, and they have drinking fountains in the lobby where they invite you to sample and take a drink of the water, which I will assure you is very tasty.
All right. Thank you.